All right, gonna look at some functions and their graphs today. Functions and graphs. A few keywords, a lot of keywords today. First one is domain. Domain is just a set of x values for a function, or also called inputs. The range is a set of y values, or outputs. A function, huge one here, correspondence between domain and range such that each member of the domain corresponds to exactly one member of the range. In other words, every x has exactly one y. Every member of the domain corresponds to one member of the range, and it's all just one. Here's a mapping diagram of a couple. This first one right here is asking you basically which one of these is a function. The first one, A, it is a function because if you look at it, everything over here, every x value is going to one y. It's all going to one. Now the second one down here has got presidents and Supreme Courts and stuff. This one is not a function. It'd be a no because if you look at Clinton, Clinton is going to two different justices. George Bush going to two different places. Barack Obama going to two different ones. Whereas up here at the top, every single X was going to just one Y. Even though they went to the same Y, that's okay. Every X was going to just one Y. This would have been the X column, that had been the Y column. Same thing here, that had been the X, that had been the Y. The second thing they're going to have you do is they're going to give you a set of ordered pairs like this and say, is it a function? And identify the domain and range. So in part A, look at the points. That one would be a no. It is not a function because this 9 right here goes to -5 and the second 9 goes to +5. So the same x has two different y's. Now the domain of that would just be your x's, which are 9 and 2. Your range on that one would be just the y's, -5, 5, and 4. If you look at the second one, all the x's are different, which means we're in good shape there, so that's a yes. That one is a function. Your domain would be your x's, which would be -2, 5, 0, and 4. I should probably get those in order. The range of your y's, 5, 7, 1, -2. And one more. See here, all the x's are different, so every x is going to one y, so that's also a yes. And my domain on the last one, I'll get these in order. -5, oh, they're in order. 0, 6. And the range on that one would be 3. Only one number in the range because they all go into 3. And that's okay. Remember, the x's, you can have just one y going to different x's. You can only have one x going to each y is the definition of a function. A function is defined by that equation, 2x squared minus x plus 3. Find each. The first thing says f of 0. Now, whenever you see this notation like f of 0, it does not mean f times 0. It means you're going to take the 0 and you're going to plug it in for the x's. So it would look like this. 2 times 0 squared minus 0 plus 3. If you notice, all I did is I put a 0 everywhere there's an x. And if I work all that out, you just get 3. That's pretty easy to work out. The second one says f of -7. I'm going to put a -7 everywhere that I see an x like this. And you got to work all that out. So it's really 2 times 49 and plus 7, because of minus, plus 3. That'd be 98 plus 7 is 105 plus 3 is 108 for that one. Part C says f of 5a, which means I'm going to plug 5a in everywhere I see an x. So I'm going to put 5a squared minus 5a plus 3. So if I square the 5a, I get 25a squared minus 5a plus 3. And I got to multiply that by 2. 50a squared minus 5a plus 3. And that's all you got to do on that one. Now the last one, probably the toughest one, says f of a minus 4. So I'm going to go f of a minus 4, which means I got to plug a minus 4 in everywhere there's an x. So I'm going to go 2 times a minus 4 squared minus a minus 4 plus 3. Now this one's going to take just a second. So I'm going to square this first. If you remember how you square things, you square the first, you multiply together double, and you square the second. This minus sign here is going to change the signs of that parentheses. And now I got to distribute the 2. Make it 2a squared minus 16a plus 32. And I still have all this stuff over here. And to finish up, I'm just going to add my like terms. The 2a squared stays. I have a -16a and a -a. That's -17a. And then add your 32 and your 4 and your 3, and you will get 39. And that's your value. So all you do when you see that notation is you plug the numbers in for x and then work it as far as you can. Okay, next thing I have you graph a couple of functions, and for today we're going to use an XY table, or we're just going to punch them in our calculator. But if I plug 0 for x, I get -5. If I plug 1 in for x, I get -4. -1 in for x, I get -4. If I plug 2 in for x, I get -1. You've done that kind of thing before. So if I plot those points here, 0, -5 is down here. 1, -4 is there. -1, -4. 2, -1. It's going to be a parabola. It's going to do this right here. So I'm going to have you graph a few like that today. The second one, do the same type thing, make a little XY table. And remember, f of x is really just a little notation for y. So if I put a 0 in there, I get 0 plus 4. Take the square root, that's 2. If I plug 1 in, I get square root of 5. That doesn't help very much. If I plug in -4, I get 0, which that may help. And let's see what else might help. 5. If I plug in 5, I will get 5 plus 4 is 9. The square root of that is 3. So that's kind of help. I'm trying to think of stuff I can plug in that will give me, like, whole numbers. So 0, 2 is here. -4, 0 is there. 5, 3 is here. And what this is going to be, I already know what it's going to be. A square root graph is like half of a parabola sideways. Looks just like that. And like I said, we'll also use our calculator tomorrow, so make sure you bring those with you. Okay, vertical line test. If you can draw a vertical line through a graph and cross it more than once, then it's not a function. It's not if you can cross it more than once. If you can just cross it once, it is a function. Let me show you a couple of these here. Move this up out of the way. Let's make these a little bigger. This first graph, if I draw a vertical line, no matter where I draw it, I can just cross the graph one time. So that would be, yes, that is a function. Yes, that's a function. Let's look at the second one here. Pull it up some. If I draw a vertical line through there, it's okay. But if I draw a vertical line through here, I hit it more than once. That's a no. And the reason this is true is because the only way to hit that more than once is if the x coordinates are the same. And remember, every x can have just one y. Let's look at a couple more of those. Third one right here, if you draw a vertical line through there, obviously you hit it more than once, that's a no. A circle, you hit it more than once, that's a no. So if you can just cross it one time, it is a function. If you can cross it more than once, it is not a function. Find the indicated function values if possible and determine whether the values are in the domain. So some of these are going to be possible, some are not. The first one says f of 1. So I would do this, I would do it, just remember, plug the 1 in. 1 over 1 minus 3 would be -1/2. That's fine. The second one says f of 3. If I plug 3 in, bad things happen. I get 3 minus 3 in my denominator, which is 0, which means that's not part of the domain. That's undefined because you cannot have 0 in your denominator, so that's undefined. Let's look at the second one real quick. G of 16, this is part B. G of 16. I'm going to plug the 16 in. It would be square root of 16 plus 5. The square root of 16 is 4. 4 plus 5 is 9. That's fine. G of -7, I would get this. The square root of -7 plus 5. And because that's not real, that's also undefined, which means -7 would not be part of the domain for that function. Domain means numbers that you can put in for x, not numbers that you cannot put in for x. You have to be able to put them in for x for it to be part of the domain. All right, this one says find the domain. We're going to do this just by looking. Now think about this right here, this first one. I'm going to make it a little bigger for you. Right there, the first one, you cannot have 0 in your denominator, which means you can't put a 7 there. So my domain would be this. It would be all x's. We did this notation earlier in the year, such that x does not equal 7, and x is all real. So x is every real number except for 7. The second one, you can factor this denominator. You could say like x plus 3, x minus 1. And when you factor that one, it gives you two numbers x cannot be. X can't be -3 because that would make that 0. X cannot be +1 because it would make that 0. So what I'm going to do is I'm going to say, okay, the domain is all x except for -3 and 1, and x is real. So x is all real numbers. X can be all real numbers except for 1 and -3. Again, domain means what are you allowed to input for x? That's what your domain is. So we're saying, okay, you can put anything in except for 7 on the first one and except for -3 and 1 on the second one. On this third one, there's no restrictions here. You can put anything in for x cubed. You can put any number in absolute value. So we're just going to say this. We're going to say our domain is -infinity to +infinity, which means you can put anything in there because there's no restrictions. Part D, cube root. Cube roots can be positive, they can be 0, they can be negative, which means on that one you can put in anything also. You can put anything in for x you want to, and it will be okay. I'll be honest with you. The only time you have to worry about domain and having restrictions like we did on these first two is if you have a fraction with a variable in it with an x in your denominator, or if you have an even root, because even roots cannot be negative. If one of those is not there, then it's going to be all reals. All right. Let's see here. What were they wanting you to do here? Well, yeah, they wanted to find a domain just by looking at the graph. So on this graph right here, that first one, move this another way. That first one, if you notice, and this is a new way to do domain also. Domain means how far your graph's going left or right, because that's how the x-axis goes. The range is how far your graph is going up and down. And if you look at this first one, it's a line and it's going left and right forever. So my domain is all real numbers. My range is also going up and down forever. So my range is also all real numbers. Let's look at the second one down here below this picture. Didn't mean to do that. There we go. Now this one, the domain is going from, it starts at -4 and it actually touches -4. So I'm gonna put a bracket and it goes forever to the right. Remember, domain is how far it's going left to right. So that's your domain. Your range is how far your graph's going up and down, and it's your y coordinates. Remember, range is your output or your y. It's touching the y coordinate right here. I'm making it really big. The y coordinate is 0, and it's going up, 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 and it's going to go up forever. So your range is from 0 to infinity. So your domain is how far left and right your graph's going. And I make sure you write it left to right. Your range is how far up and down your graph's going. You're going to write that one down to up. Let's look at a couple more. Make sure we got that pretty good. This one right here, the third one, that's a cubic graph. And it's actually going left and it's getting wider and wider as it goes. So the domain is all real numbers, -infinity to +infinity. Your range, it's also going up and down forever. So it's also the same thing, all reals. And one more here. This one's going to be a little trickier. If you look at this last one, it's going left and right forever. However, it skips. I don't know if you can see that there's a little red thing on the graph right there. It's actually skipping the 2. So what I'm going to do is I'm going to say, okay, my domain is going to be all x's except for 2, and x is real. So all reals except for 2. My range, it's going up and down forever, except it never touches the x-axis. So my range is going to be all y, except for y cannot be 0. There's no way for it to equal 0. And y is also real. I need to watch that one more time. Again, x, your domain is how far your graph goes left and right. Your range is how far it goes up and down. And if it skips a value, you need to put that in your notation. Okay, last slide. This just wraps everything up. If you have a function like this one, I went and drew the graph over here. For every input, there's exactly one output. Or for every x, there's exactly one y. It passes the vertical line test. 1, 6 is on the graph. The reason 1, 6 is on the graph is because if you plug in 1 for x, you get 6 right there. If you plug in 1 for x, you get 6. That's why it's on the graph. The domain, because it's going left and right forever, is all reals, or we write that -infinity to +infinity. Your range, if you look at it, the top point on the graph is 6, and it's going down forever. So remember, you have to go least to greatest in your notation. So we had to write, okay, it's from -infinity up to 6. That's as high as it goes. That's your range. That is a really good slide. Kind of has the whole entire lesson in that one slide. So a lot of stuff today. We'll go over it like we always do tomorrow. Can't wait to see you then. See ya. Bye.